My name is Tanay. I'm a rising senior at Cupertino High School. The project I'm working on is object detection using Raspberry Pi. For my second milestone, I found a way to calculate the density of a parking lot. In essence, the amount of parking lot that is taken up. I ended up using a pixel method, where I calculated the pixels of the bounding boxes around the cars and the total pixel area and used a ratio to plot the density of a parking lot. The problem was quite complicated and took a lot of brainstorming to figure out a way to solve the problem. I started by calculating the total area of the bounding boxes around the car. I did this by looping through predictions. I'm highlighting here. I looped through predictions, and for each of the predictions in the list, I essentially calculated the area of the bounding boxes and added it to a variable called bounding box pixels. The only problem with this approach is that many of the rectangles are overlapping, and by by doing this method, I'm double counting that overlap area, which leads to inaccurate results. So to solve this, I needed to find a way to calculate the overlap area between each of them. So my solution was to basically get a list of lists, which represented the rows of the rows of the cars, as I highlighted right here. So to do this, I made a list of rows of cars and added cars to each of the rows depending on if their y midpoint coordinate was within a 10% buffer. And that code is down here. This worked well, and the result was a list with each of the rows of the cars. I then looped through this list and calculated the overlap between rectangles and subtracted the value from the total bounding box area. So to calculate the overlap area, I had a function here, which took 8 points, which represented the two rectangles, and calculated the area of intersect. The next step was to find the total area of parking space. And this was very simple because since I already have a list of the rows of cars, I simply had to take the first element in that list of row and the last element and calculate the area of the rectangle that goes around the entire row. So then I simply divided those two values, and the ratio between those two values yielded roughly 75%. This was extremely accurate because the parking lot I used had 35 spots with 26 cars, which is a ratio of roughly 75%. This is my second milestone. I learned a lot about Python, about coding in Python, how to solve programs through programming. Thank you.